Okay, do you remember the last class? We did minimization of DFA and equivalence between two automatas. Okay, this one completed. Today we'll start construction of DFAs. What is DFA? Anybody please respond. What is DFA? Hello. What is DFA? Where is Kumar?
Deterministic finite automata.
Oh, I'm not asking you the full form of DFA.
So in DFA, every state must be defined for every input, and at every state, for every input symbol, it must have single output.
Good, very good. So, what about that girl last time gave me the answers? I forgot her name. Is she in this class now? I forgot the name. Okay. Now, construction of DFA, minimal DFA, means the least possible number of states. Here, the meaning of minimal, the least possible number of states. Construct a minimal DFA. All of you note on this. Construct a minimal DFA over set 0, 1. This is set over set 0, 1 that accepts all strings ending with 0. It accepts all strings ending with 0. Okay. Now, what is DFA? Every state must be defined for every input. That is one condition. And the second condition is at every state for every input, it must have single output state. Okay. Here, the strings are the combinations of zeros and ones. Means it can be any combination 0 or 1. It can be any combination of zeros and 1. And it should ending with 0. See here, this x means either 0 or 1, 0 or 1, 0 or 1, 0, so on. It can be of any length, and if the last symbol is 0, it must be accepted by the DFA. That is the question. Okay, so among here there will be so many strings. Example, 0 0 is the ending with 0, and 1 0 is the ending with 0, and 1 1 0, similarly 0 1 0, like this. There will be so many strings ending with 0. Can you say what is the smallest string among all these? Hello, there will be so many strings ending with 0. Examples, these are the strings. And among all these, what is the smallest string ending with 0?
0 itself.
Very good, excellent. So 0 is the smallest string. So whenever you are constructing any DFA, first accept the smallest string. First accept the smallest string. Here, what is the smallest string? This is the smallest string. Now, how can we accept a string by finite automata? By starting at initial state. I repeat, starting from initial state. If we stop in a final state, then the string is said to be accepted. So for that, we must have an initial state. So I am taking this as initial state, and whatever the smallest string, just we accept it as it is. So for this, we need a final state from initial. From initial, we go to final on input 0. So look at this. This is the rough diagram. Okay, here we have not defined at every state for every input. Here the inputs are zeros and ones, so we must define at every state for 0 and 1. Okay, now here in the initial state we have defined for only 0. Now here 1 comes, in the initial 1 comes, what to do? In the final state 0 comes and 1 comes, what to do? So that the string must be accepted if it is ending with 0. Okay, now look at this guy. If the string is 1, shall I accept? No, because it is not ending with 0. Okay, so every time we start from initial. So here in this state, if 1 comes, I can go to this, means I can remain in this, or I can go to final state. There are two options I have, because as we have two states only at initial state, if 1 comes, we can define itself, or we can go to final. If we go to final on 1, suppose if I go to final on 1, so means it will be accepted. But the string is invalid, because the string is valid if it is ending with 0 only. As the single one is not ending with 0, so we should not go to final. So that is the reason on single one, we must remain in the same state only. Okay, so at initial state, if 1 comes, we will remain in the initial only. And again 1, yes, same state initial. Again 1, again 1. As long as 1 comes, we will be in the initial. Suppose 0 comes, yes, it is ending with 0. That is the reason. See, already we have defined. We will go to final. And again 0, yes, it is ending with 0. So as long as ending with 0, it must be accepted. That is the reason in the final, as long as 0 comes, we will be in the final. And again 0, final, like that. Again 0, as long as 0 comes, we will be final. Suppose 1 comes, no, it is invalid, because it is not ending with 0. So in the final state, if 1 comes, we will come back to initial. And here 1 comes, initial, that is non-final. Again 0 comes, final. 1 comes, non-final. 0 comes, final. 0 comes, final. So this is the perfect DFA for accepting all the strings ending with 0. See, initial state has defined for 0 and also 1. At initial state on 0, single state. At initial state on input 1, it is having single output state. And at final state on 0 and on 1, we have defined. At final state on 0, it is having single output. At final state on single 1, it is going to single initial or single 1. Okay, so this is the DFA. Now I have one doubt. Look at this. Here the machine we require is which accepts all the strings ending with 0. Okay, now look at this. As long as 0, this one 0 final, again 0 final, again 0 final. As long as 0 comes, it will accept. And if ending with 1, we are going to non-final. Ending with 1, non-final, again 1, non-final. And if suppose 0, then final. So look at this diagram. If the string is ending with 0, it will be in the final. Ending with 1, non-final. Ending with 1, non-final. Again 0, final. So this automata is also accepting all the strings ending with 0. And the first automata, which I have explained till now, this one, this is also accepting ending with 0. And this is also accepting ending with 0. This one. Now, among these two, which one is correct? Or both are correct, or only one is correct? Are you following? Guys, do you hear me?
First one is correct.
Why first one only correct? This is also accepting all the strings ending with 0, na?
Sir, the second one will also accept the empty string.
Very good. Okay. Whenever a machine is perfect, it must accept all the valid. No doubt, this machine accepts all the valid. It accepts all the valid strings, and also it will accept an invalid string. I repeat, if a machine is perfect, it must accept every valid string. At the same time, it should not accept even one invalid string. The machine should not accept invalid string. And if you take epsilon, epsilon is not a valid string, because the strings here are should ending with 0. epsilon is not ending with 0, so it is invalid. But this machine accepts epsilon as initial is final. I told you initial is final, so it accepts epsilon. This machine is accepting epsilon, which is invalid. So that is the reason, even though this machine accepts all the valid string, as it is accepting invalid epsilon, that is the reason this is not a correct diagram. Only the right diagram is the first one. So this is invalid. Okay, so copy this. So I repeat, every time whenever you require to consider any DFA, you first take the smallest string and you accept that string, and then so to accept you consider a rough diagram, then you make it into DFA, convert into DFA. Okay, next question. So similar question I'm giving you. Construct a minimal DFA over set 0, 1 that accepts all strings ending with 00. This is the question. Okay, here the string is of combination of zeros and ones. Please, someone of you, okay, hello, please mute from your side. Hello, please mute from your side. I'm getting some disturbance. So here the string is of any combination of zeros and ones, and it should be ending with 00. So ending with 00, there will be so many strings, but the smallest string is 00. So accept 00 first. This is for first 0. And this is for second 0. Single 0 is not valid because it is not ending with 00. So that is the reason from initial on single 0 we are coming to this state, and it is a non-final state. It means not accepted. Okay, now this is the rough diagram. Now we have to convert into DFA. So as long as one in the initial, I will be in the initial only. Again one initial, again one initial. Now 0 comes, I will go to the second state, allow this state here. And in the second state, again one comes. Suppose, look at this guys. In second state, one comes, I will be here. Okay. Now, again, if 0 comes in the second state, means from here will come to the final, means accepted. So this string is accepted. Actually, what kind of strings must be accepted if it is ending with 00? Is this ending with 00? No. This is ending with 10. So the invert string, it is an invert string. So invert string is accepted with this machine. So this is not correct. So what is the wrong in it? I will tell you. In the initial, as long as 1 comes, we will be in the initial only. And once 0 comes, we'll come to the second state. So suppose this is Q0 and this is Q1 and this is Q2. So on 0 in Q0 will come to Q1. In Q1, if again 0 comes, then we'll go to final state. But instead of 0 in Q1, if 1 comes, here the order has disturbed. Actually, what is the order? After single 0, after first 0, again we require the second 0. But instead of second 0, if 1 comes, whenever order has disturbed, go back to the initial. So in Q1, 1 comes, will go back to initial. And again 0 comes, from initial Q0 to will come to Q1. See, Q1 is a non-final, not accepted. Again 0 comes, yes, this is ending with double 0. So we'll go to Q2 final. And again 0, yes, all these things are valid. So in final state, as long as 0 comes, we will be in the final. Suppose here 1 comes, shall I go to Q1? If I go to Q1, okay, I'll go back to Q1. Now we are in Q1. In Q1, if 0 comes, it will come to Q2. So accepted. So that is the reason this is not the correct. Okay, so in Q2, in the final state, if 1 comes, in the final state, if 1 comes, means the order has disturbed. So so whenever order is broken, we'll go back to the initial. So in final, if 1 comes, go back to the initial. Now in initial 0 comes Q1, not accepted. In Q1 0 comes Q2, final state. So this is the way of constructing the DFS. So copy this one. Any doubt regarding this? Hello? Does anybody has any doubt? Next. Similar question. Construct a minimal DFA over set A comma B that accepts all strings. Actually, till now we have done strings power 0 1. But for a change, I have changed the input. So instead of 0 1, I gave you A comma B or A comma B. Same, ending with triple A. We did ending with 0, ending with double 0. Now we are doing ending with triple 0. Instead of triple 0, I gave you ending with triple A. And second question, not ending with triple A. Third question, having substance triple A. So these all three are different questions. Our set, our input A comma B. So try this. Okay. Now, first one. Check this answer. The smallest string is AAA. The smallest string is AAA. So from initial, we'll go to final on first A, second A, third A. And in the final state, as long as A comes, we will be in the final only. So because as long as A comes, they are ending with AAA. So wherever in the second state or in the third state or in the final state, whenever B comes, we'll go back to the initial. We'll go back to the initial. See? So this is. So same as, see here also we did the same. From initial 0 comes, will go. So wherever 1 comes, in Q1 1 comes or Q2 1 comes, in initial 1 comes, we will be in initial. Okay. So this is. You got the same?
Yes, sir.
Okay. Any doubt, guys? Anybody? Now, what is the difference between the first question and the second question in these two? Yeah. The first question ending with AAA. So it is of any combination of A and B. And if the last three symbols are A's, it will be accepted. In this first question. In the second question, in the first question, the language will have all the strings ending with the last three symbols are A's, ending with 3 A's. For the second question, it will have any combination of A and B. I'm talking about the language. I'm not talking about the automata. The second language, this one, it will have any combination of A and B, but it don't have the strings if the last three symbols are yes. These kind of strings will not be there. So again, for the first language, for this language, the automata accept all the strings if the last three symbols are yes. And for the second language, the automata must accept any string, any combination of A and B, but if the last three symbols are yes, don't accept. I repeat, for the second question, the automata should accept any string of A and B, and if the last three symbols are yes, it should not accept. Whereas the first question, the automata must accept only the strings in which the last three symbols are yes. Therefore, in the first language, this one, first question, whatever the strings in the first language will not be in the second language. Whatever the strings in the second language will not be in the first language. So here the 1 and 2, the first and 2 languages are complement each other. And already we have done the automata for the first question. As 1 and 2 are the complement languages. Now, as this is the automata for the first language, we need a complement of this automata. Okay, so simply the automata we want which accept any combination of A and B, which should not accept if the last three symbols are yes. Otherwise, you accept every string. That is the second question. So this is the answer for the first question. So we want the complement of this automata. So complement of an automata will be formed by. Will anybody say? I want the complement of this automata. Complement of an automata will be formed by
making final
So interchange
states, non-final states, and non-final.
non-final still final and final will non-final.
simple. Interchanging final and non-final states. Good. Interchanging final and non-final states of an automata. See, we want the complement of this automata. By interchanging final and non-final, we will get the complement of this automata. Means simple. So just copy as it is. Here I am drawing. Sorry. So this is the diagram as it is to the above only, and then here this is the first one automata. So I want the complement of this one. Complement of an automata will be formed by interchanging final or non-final. Means in this automata the fourth state is final, so here the fourth will be become non-final, whereas here in the automata 1 2 3 are the non-final, whereas in this 1 2 3 will be final. So this non-final will become final, these three will be final, and whereas this last final will become non-final. So you take any string, it accepts any string. Example, I'm taking B, yes, it will be accepted. BA, yes, BA is going to final. BAA, yes, it is going to the final. And now BAAA. See, this is ending with AAA, so it should not be accepted. Look at this BAA, yes, we are going to this non-final. And suppose again B comes, then it will come to this final state. So this is A, guys, this is A. And as this is not ending with AAA, it will go to the final. Again A, yes, final. Again B, yes, final. It accepts every string of every combination of A and B except the last symbols are AAAs. The last three symbols are A's. Okay. Now copied. Hello, any doubt in this? So take the heading complement of an automata. Complement of an automata. By interchanging final or non-final states, by interchanging final or non-final states, the complement of a given automata will be formed. The complement of a given automata will be formed. Okay. Next. Having substring AAA. Means, already I told you what is the meaning of substring. Anywhere consecutive part of a string. Example, AAA can be in the starting, 3A's continuously can be in the middle, or 3A's can be in the ending. So all these strings are having substring AAA. So here also, the smallest string having substring AAA is what? The smallest string having substring AAA is what? Are you following? What is the smallest string?
AAA itself.
AAA can be in the starting, can be in the middle, can be in the ending. What is the smallest string?
AAA itself.
What is AAA? So accept AAA first. 1, 2, 3. So as the smallest string is AAA, from initial we'll go to final on 3 A's. This is the first A, and this is the second A, and this is the third A. Now guys, tell me, is this string valid or invalid? Hello?
Valid.
Valid string, because already it has triple A. So once you get that 3 A's after reaching the final state, it can be any combination of zeros and one. So in any combination of A and B. So once we reach the final state, we will be forever in the final. But when do we go to the final? If 3 A's comes consecutively. So in the initial, if B comes, we will be in the initial only. Okay. In the initial, if A comes, we'll go forward. And in the second state, if again B comes, see, order has disturbed. So come back to the initial. And initial A comes, again go to second state. Again A comes, go to third state. Now if B comes, again the order is disturbed. So whenever the order disturbed, come back to the initial. So this is for B. And now initial A comes, go to second. And from second A comes, go to third. And from third A comes, yes, we have 3 A's. Go to final. After that, for any combination, be in the final. So this is the diagram for substring. So remember this point, substring means we will go to final and we will be forever in the final. That is the meaning of substring. Okay. Copy this one. Next. I'll give you one question. Take this question. The complement of the given DFA accepts.
All strings not ending with ABB.
These are the options. First one, all strings ending with ABB. Second one, all strings and starting with ABB. And third one, all strings having substring ABB. Hello? Answer, please.
Option A.
Some girl has given me the answer before I give the options. So what is your option now?
So A.
Who is this?
Siley.
Okay. So what did you say earlier first, before this?
All strings not ending with ABB.
Okay, guys. What about the others? What do you say? I am not asking about the given automata. I am asking you about the complement of the given automata. So first we must check about this automata. So how to check this one? From initial, how can we go to final? First we check that. So from initial on A will come to here, from here to here on B, and from here to here B. So it accepts ABB. This is the smallest thing. So ABB, what is ABB? Maybe starting, maybe ending, maybe substring. So how can we analyze this? Suppose after reaching the final, what can come? A or B comes. Suppose A comes, then it is going to this state, and from here to come to final again BB. So it is looking like the machine accepts ending with ABB. Let us check. In the final state, if B comes, suppose A comes, it will come to this. If B comes, then it go to this initial state. From initial, how can it come to the final? On ABB. So this automata accepts all the strings ending with ABB. So this automata accepts all the strings ending with ABB. So now we want the complement. So complement means complement means you just add the word not ending with. What is the complement? By making the non-final as final and final as non-final. So if I make this all three as non-final and this is final, it accepts every string except the last three symbols are the ABB. So this the complement. Therefore, the complement accepts the complement of the automata accepts all strings not ending with ABB. Not ending with ABB. Is it there? Is it there? No. So answer is none. Then why did you change the option? That girl. Before I give you the options, you told me right answer. But after options, your answer was wrong.
So I missed one case where the string is only ABB, so it will start as well as end with ABB.
Okay, so remember, complement means add the word not. That's it. So don't misunderstand ending with ABB. Complement will be starting with ABB. Not like that. Suppose if I give you any machine starting with ABB, then its complement accepts all the strings not starting with ABB. So add the word not. Okay. So it is not, as it is not given, the option will be D. Is it clear? Guys, hello.
Yes, sir. Yes, sir.
Next. Copy this. Starting with either AA or BB, ending with either AA or BB. And one second. Hello. Did you all copy this question? Just hold on. Okay, don't take that question. One second. Please copy this question. So we'll do that question later. We'll do this question first. Construct a minimal DFA over A comma B that accepts all strings. First one starting with A, second one ending with B, third one starting with A and ending with B, and fourth one having first and last states are different. Last symbols are different. Having first and last symbols are different. And fifth question, having first and last symbols are same. Do you understand? Hello? So leave the previous question. First we'll do this question, then we'll go back that. Third question is starting with A and ending with B. And fourth question, first and last symbols are different. Fifth question, first and last symbols are same. Okay. First question I'll complete. Starting with A. What is the question? Consider a minimal DFA over set A comma B that accepts all strings starting with A. Means the first symbol must be A. After that, it can be anything. The first symbol only A. After that, it can be anything. So here, what is the smallest string? The smallest string is single A. So you accept single A. So for that, we need initial, and from initial we'll go to final on A. Okay, this is the rough diagram. Here the first symbol should be A. After that, it can be anything, because the first, if it is starting with A, then accept. After that, it can be any combination of A and B. Suppose instead of first symbol A, if the first is B, after that whatever comes we don't want. So first symbol A, then only we'll go to final. If first is B, we should not accept. For that reason, here we must go to dead state. Here, see, up to now in the previous questions we have not used the dead state. So now in this construction we are using the dead state, because the first symbol, if it is B, all those are invalid. So that is the reason on B we'll go to dead state, and dead state also must be different for every combination of A and B. So this is okay. Dead state also must be different for every input symbol. Okay, any doubt? Did you get the same? Hello, did you get the same?
Yes, sir. Yes, sir.
Okay, next question. Ending with B. Ending with B. Second question, ending with B. Ending with B means the last symbol must be B. So what here, what is the smallest string? The smallest string is B. The smallest string is B, because B is as well as starting and also ending. So first we accept the single B, ending with B. Now see, B will go to final, and as long as B comes, yes, all these strings are ending with B. So as long as B comes, we will be in the final. Suppose A comes, it is not ending with B, so come back. And in the initial, as long as A comes, we will be in the initial only. And suppose B comes, yes, ending with B, go to final, again B in the final, again B in the final, again B in the final. If A comes, go to non-final, that is initial. Okay, this is the EFA for ending with B. Here, we have not used the dead state, because dead state won't come in this. So if ending with B, we will be in the final. If ending with A, go to non-final. Again B comes final. As long as B comes final. If A comes, go to non-final. Again B comes, come to final. That is the reason here we should not use the dead state. And whereas initially B comes, all those are invalid. That is the reason we'll go to dead state. Next, starting with A and ending with B. You try these three. I will give you some time. You please try all these three. Done? Completed? Anybody completed the remaining 3?
Yes.
Okay. Okay. Starting with A and ending with B. So here, the smallest string is AB. Starting with A and ending with the smallest string is AB. So accept AB first. A, then B. So from initial, we'll come to this on A and ending with B. Now, so convert into DFA. Starting with A. If the string is starting with B, we should not accept. So that is the reason here we require the dead state. Because starting symbol should be A. Instead of that, if the starting symbol is B, we must go to dead state. And if starting with A, we'll go towards the final. Again A. As long as A comes, we will be in this state. And if B comes, we'll go to final. Again B comes. Yes, as long as B comes, it is ending with B. So B in the final. And again A comes. It is not ending with B. So that is the reason come back. And here we will be in the state as long as A comes. Again A will be in the same state. Suppose B, yes, ending with B, then go to final. Again B, yes, B in the final. So this is the way of constructing. So every time A comes, what to do, B comes, what to do, so that this valid string must be accepted and invalid must be rejected. Okay. Next, the first and last symbols are different. Fourth question. Copy this one. Yes, fourth question. Okay, first and last symbols are different. What do you mean by that? If starting symbol is A, then should end with B. Or if start symbol is B, then should end with A. So, initial. If starting with A, then ending with B, the smallest thing is AB. If starting is A, then end with B, this is the smallest thing AB. Here, as long as B comes, we will be in the final. and here A comes, will come back to this second state, and as long as A comes, will be here, and ending with B, go to final. And similarly, if it is starting with B, then should end with A. So this is, if starting with B, then should end with A. And here, as long as ending with A, will be in the final. And if B comes, we'll come back to this. And here, as long as B, we will be in this one. So here we have two find states. An automata can have any number of find states. Anybody got the same?
Yes, sir.
Okay, good. Next one. Having first and last is the same. Having first and last is the same. Here, tell me, having first and last is the same, what is the smallest string? Having first and last is the same, what is the smallest string?
Only
A or VB.
or
A or
only
B.
B.
Only
Huh?
A or only B.
Very good, excellent. Yes, only A or only B. Good. Starting with A and ending with A, and starting with B and ending with B. So AA the one string, and BB is also valid, and these are the not smallest strings. This is the smallest one. Here the first symbol is A, and second last symbol is also A, and similarly first symbol is B, and the last symbol is also B. So A and B are the smallest strings. So accept first A and B. Now if first is A and the last is A, we'll go this one, and the smallest thing is A, and as long as ending with A, because this is first symbol is A, and as long as ending with A, B in the final. If it is ending with B, non-final, and here as long as ending with B, non-final, and ending with A, final. This is for first and last symbols are A's. And similarly, the smallest string is B also, so go to final. And as first is B, as long as ending with B in the final, and if it is ending with A, non-final, and as long as ending with A, non-final, ending with B, final. So this is the diagram for first and last symbols are same. All of you got the same?
Yes, sir.
Anybody has any doubt, or if anybody got the different answer, you please let me know. I'll tell you whether it is correct or not.
Sir, hello.
Yes. Yes.
Sir, can we not get this answer by taking complement of fourth question?
What is the fourth question?
Sir, first and last symbols are different.
Hmm.
I mean, yeah. So,
Very good.
uska opposite will be first and last symbol.
One second. These three will be the final. Okay, na? And this will be the non-final.
Yes, sir.
This one will accept every string.
Very good. This accept epsilon also. Epsilon is neither the first symbol is A nor last symbol is A. Epsilon is nothing, empty string, so should not be accepted. That
Yes,
is the
sir.
only. Okay.
Okay, sir.
Take this question. These are the options. The language accepted by the given machine is. So copy the machine and options I'll show you later. First copy the machine. Copied. So copy these options first. First one, all strings having ABB as substring. Second one, all strings not having AA as substring. And third one, all strings in which every A is followed by at least two B's. And D, all.
Sir, can you show the diagram, please?
Yeah, okay. No, will you please leave the space and copy these options. And we'll go back to the machine. So diagram length is this much. Okay. So all strings having ABB as substring, not having A as substring, every A is followed by at least two B's, and D option all. Okay. Now this is the diagram. Did you all copy the options? Is anybody still copying? Okay. Take this diagram. So tell me the answer. Hello. Are you there? Nobody is talking.
Option A.
D, option D.
Option D.
Option
Option
D.
A.
D.
Huh? Second option.
D.
So I did not check all the options.
I got A, I got B, I got D. If anybody says C, then all. So all options I got. Oh, very good. I got A, B, C, D all. Last time one girl told me the answer that 7 into 2 power 7, that question number of final states. Who is that girl? I forgot name. Bhagyasri or Bhargavi something.
So Bhargavi.
Bhargavi. Is she present today?
Yes, sir, it's me.
Bhargavi, answer. Bhargavi, are you late today or you joined earlier?
As I am late today.
Okay.
Sorry, sir.
No problem, miss. That is okay. So, what is your answer? When did you join? 9:30? Sorry, 8:30?
As a 9. 9,
9.
sir.
Okay. So, anybody?
Sir, D.
D.
Yes, sir, D.
Shayali? Shayali, some
D. D option.
B, second one.
No, sir. Fourth one.
Oh, D, okay. Oh, okay. So, still anybody trying or shall I go for solution? This is the previous question. Shall I go for the solution or still anybody trying? Okay, look at this. First one. All strings starting with all strings having ABB as substring. Is this correct or not? All strings having ABB as substring. Okay. Let me check. ABB as substring. The last smallest one is ABB. So is the machine accepting ABB? ABB, yes. And again becomes yes. Again becomes yes. If A comes, now from the final, we are coming to this state on A. So this string is having ABB as substring. So this string must be accepted as per the first option. But see, A, B, B, then B, 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 then A is not accepting. This string is not accepting. And then in this case, this is not correct. When A is not correct, obviously D is not, because all ABC is not correct. So whoever opted A and D, they are wrong. Okay. Now, all strings not having AA substring. This means, according to the second option, if AA is there in the string, if AA substring is there, then it will not be accepted. Otherwise, it accepts every other string. That is the meaning of second option. So let us check first. And this one is having AA. So according to the second option, it should not be accepted. Let us check B. Initially, B comes, it will be in the initial. A comes, second state. On A comes, dead state. And B, okay. Okay, perfect. In this case, it is perfect. Okay. Now, what is the meaning of second one? If AA is not there, if the substring AA is not there, it will be accepted. Otherwise, if AA is there, it won't be accepted. Suppose AA is there, yes, it is not accepted. And suppose AA is not there. In this string, AA is not there. If AA substring is not there, yes, we don't have AA substring in this list. So, according to the second option, this string must be accepted. Are you following us? What is the second option? In the string, if AA substring is there, it won't be accepted. In the string, if AA substring is not there, it will be accepted. Let us check this one. A, this, then B, then B. From the initial, it will come back to this state on A. So it is non-final, not accepted. So the second option is also not correct. The second option, according to second option, if AA substring is there, it will not be accepted. Okay, it is not accepting. In this case, it is perfect. And suppose AA is not there, it should be accepted according to the second option. If AA is there or AA is not there, it is not accepting. So the second is not correct. Now, so when A, B, D not correct, then C is how this is. Look at this. All strings in every A. You have to notice this one. Observe this. Every A is followed by at least 2. This means this machine accepts any combination of A and B in which whenever A comes in the input string, it is followed by at least 2 bits. Every A followed by 2 bits. Okay, that is the meaning of at least 2 bits minimum, or it can be more. So let us check. Suppose B, as long as B comes, no problem. If A comes, yes, every A, then minimum 2 bits. Again A, minimum 2 bits, or can be more bits. Again A, minimum 2 bits or more bits. So as long as B it is and A, then one B and second B, it can be any number of bits. Again A comes, it will come back to reach the final. Again minimum 2 bits. Okay, if anybody saying, sir, this thing is not accepting, so how it is correct? So here this is not correct as per the third statement. Every A, here A after minimum 2 bits, then again A after minimum 2 bits. So whenever A comes, it must accept A, then followed by minimum 2 bits. Again A minimum 2 bits, like that. So option C is correct. Any doubt?
Sir, can you please explain why B option is wrong?
What is the meaning of the second option?
Not having AA as substring.
So what do you mean this one? It accepts. What is the question here? The language accepted by machine is not having AA substring. If AA is not there, it will be accepted. Now, in this string, AA is not there, so it must be accepted. Okay, now, so let us check A. On the A, it comes to the second, on B, third, on B, final, on A, again to the second state, not accepted. So, according to the second option, in the string, if AA is there, it will not be accepted. This is rejected. This string will be not accepted. Okay, another second option. Suppose AA is okay, AA is not there. If AA is there, it won't be accepted. AA is not there. This string is not having AA, so this must be accepted. This must be accepted, but it is not accepting. Bhargavi, is this Bhargavi?
No, sir. Sir, AA is not accepted, na?
Ma'am, what is the second option? It accepts all strings not having AA as substring. He is saying that in the second option, it accepts every combination of A and B in which if AA is not there, if AA is there, example AA is there, suppose this is having as AA substring, it will not be accepted. It will be not accepted. Okay. Suppose when this, according to this second statement, AA is not there, it will be accepted. AA is not there, it will be accepted. Suppose AA is there, it will be rejected. Okay. So let us check this one. This as per the second option, it is having AA, so it should not be accepted. So this is B. In this case, the statement is correct. The statement is correct. Okay, according to the second statement, this machine accepts all strings if that string is not having AA. That is the meaning. So I am taking another string which is not having AA. Hello, miss. In this, do you have AA substring?
Yes, sir. No.
Hello, miss. In this string, do you have AA
Hello?
substring?
Hello?
Yeah, tell me, ma'am. In this one,
Hello, sir. Your
do
voice
you,
is not properly
hello?
audible. Hello?
In this string, do you have the substring? Hello, what happened?
Hello? Sir, just a second.
Guys,
Sir, just a
guys,
second. I'll
others, can
join again.
you? Others, can you? Hello, guys. Is my voice audible to others?
Yes, sir.
Yes,
Yes,
sir.
sir, you are audible.
Problem is that side. Okay, do you have any doubt in this? In the second option, it accepts every string. If AA is not there, it accepts all strings if AA is not there. So according to this one, yes, this is not having AA, it must be accepted according to the second option. But this string is not accepting.
Yes, sir.
Okay, shall I repeat?
No, sir. No, sir.
So, is that girl same? You asked me the doubt?
Yes, sir. Yes, sir.
Okay. So, it accepts if AA is not there. And if AA is there, it will not be accepted. Okay, that is the second option. But it is not accepting even though AA is not there. That is the reason the second option is not correct. Whereas it accepts every string in which A is followed by minimum 2 bits. Quick, come back to this one. Earlier I gave you this question, then we jump to another. So copy this one. Construct a minimal DFA over A comma B that accepts all strings. First one, starting with A, starting with either A or BB, next ending with A or BB, having substring A or BB, next having substring triple or triple B. Starting with AA or BB. Starting with AA or BB, the smallest string is AA or BB here. Starting with AA, either AA or BB. So here the smallest strings are AA and BB. So accept first AA. One second. Starting with AA. After that, anything. Starting with AA or BB. So if the first two symbols are A's, then after that it can be anything. Similarly, it can be starting with BB. So first two symbols can be B. So first is B. and second is also B. Then after that anything. Okay. So either first two symbols are A's or first two symbols are B's, it will be accepted. Suppose first is A then B. No. Suppose first is B then A. No. These two kind of things should not be accepted. The first is A, the second is B. Then first is B, the second is A should not be accepted. So either first two symbols are A's or first two symbols are B's. So we'll go to final. Suppose the first symbol is A and then the second symbol is B, dead state. Or first symbol is B, then second symbol is A, then also dead state. And dead state also must be different for every input symbol. So did you get the same? Hello? Did you get the same?
Yes, sir.
Yes, sir.
This is dead state. Next. Ending with AA or BB. Second question. Ending with AA or BB. Here the small strings. Ending with AA or BB. So here also small strings are AA and BB. Similarly, ending with BB. The smallest string is BB. Okay. Ending with AA. As long as A comes, it is ending with AA. Ending with BB. As long as B comes, it is ending with BB. And suppose starting is A, then B, no, it is invalid. So if A, from initial A comes, we'll go to this. If B comes here, then, and again B comes, yes, ending with BB. So it will go to the final. And as long as B comes, final. If A comes, it is invalid. So here A comes, it is this one. And here A comes, yes, it will go to final. As long as A comes, B in the final. Suppose B comes, it is invalid. It comes to this. And here B comes, yes, it is ending with BB. It will go to the final. And A comes, it will go to this one. And here B comes, it will come to this state. And here A comes, here it is invalid. So here. And after that again A comes, it will go to final. So every time, wherever the machine is, whatever the state the machine is, if it is ending with A or BB, it will go to any of these two states. If it is ending with AA, it will go to this. Ending with BB, it will go to this one. Otherwise, it will be in the non-final. Any doubt? Shall I go for next one? Anybody got the same? Hello?
Yes, sir.
Yes, sir.
Okay, next
Yes,
one.
sir.
Having substring either AA or BB. Having substring either AA or BB. Third one.
Sir, can you show the question once?
Third question. Completed? Having AA or BB a substring. Having AA or BB a substring. So here, substring means we go to final and we will be forever in the final. Here the string can have either AA or BB. If this is substring means we will go to final and we will be forever in the final. So remember this point. Similarly, BB, B, B. Okay. So suppose A comes then B, no, invalid. And similarly, B after A comes then also invalid. But once you get either A, 2 A's or say, yes, see, for this A, it comes to the final state. Or instead of that, if B comes, it will come to this state with this one. And here B comes, it will go to final. So once either 2 A's or 2 B's consecutively, then it will go to final and it will be in the final forever. Anybody got the same? Hello?
Yes, sir.
Anybody got it? Okay.
Yes, sir.
Next.
Yes, sir.
Next. Triple A or triple B as substring. The third one is double A or double B. Now, fourth one, triple A or triple B as substring. This one, having substring either triple A or triple B. It is moving. Triple A. 1, 2, 3. And we go to final and we will be forever in the final. And triple B. 1, 2, first B, second B, and this is for third B. Here B comes similarly here A comes, and here B comes. What shall I do? In this state B comes, come to this. Here A comes, this is. So who did this? Anybody got the same? Triple E or triple B?
Yes, sir.
If anybody is having doubt like this, sir, why did you construct like this? Why cannot we do like this one? Suppose. Sir, actually, in this state B comes, you came to this one. No, sir, I will construct like this. This is B, and this is A. I will do like this. If anybody got this one, if anybody had drawn it like this, now tell me, if this thing is valid or invalid? Hello, if this thing is valid or invalid? Double A, double B?
Invalid.
Invalid, because this is neither having AA and neither having triple A nor triple B. So this thing should not be accepted. If anybody consider like this, first A, it comes to this state, and second A, it comes to this state, and on B, so this B, it comes to this one, and for this second B, it go to the final state. So this is not correct. So if anybody consider like this is not correct. Okay. Whereas, look at this our diagram, and for first A, it comes to this state, and second A, it comes to this state. On this B, it comes to this state, and on B, it comes to this state, and it is non-final, not accepted. So yeah, this is invalid string, it should not be accepted. Yes, we are not accepting. Any doubt? Shall we go for next one?
Yes, sir.
One second. We'll do some interesting question. Okay. Look at this. I am giving you two states, Q0, Q1. Listen to the question first. I am giving you the two states, Q0 and Q1. And in these two states, always Q0 is initial. Q0 is always initial. And I'm giving you the two inputs, 0 and 1. I repeat, I'm giving you the two states, Q0 and Q1. Always Q0 is initial. Q0 is initial. And I am giving you two inputs, 0 and 1. So you have to construct a DFA. So with this data, with this constraint, how many DFAs you can construct? I repeat, if there are two states, Q0 and Q1, and always Q naught is initial, and our two input symbol 0 and 1, how many DFAs you can construct? Okay, so in this state, I'm not giving you any final. You take anyone is final. Your wish. You can take anything as final. Okay, but just I am giving you two states. Whether you are taking final, non-final, that depends on you. But always Q naught is initial and Q1 is the second state. And if you construct DFAs, how many DFAs you can have? So take the question now. The maximum number of DFAs that can be drawn over set 0, 1 with the two states Q0 and Q1, having always Q0 as the initial state is. Do you understand this question? What? No one is responding. Shayali, are you trying?
Yes, sir.
The number of DFAs that can be drawn over set 0, 1 with two states having always Q0 as initial is.
Sir, is it option B?
Option?
Is it B?
Second option?
Yes.
Second option. 16. Huh?
Yes.
Mister? Hello, mister?
Yes, sir. Hello.
Bhagyaji, answer. Yeah, tell me, Mister. Tell me.
Sir, is it option B 16?
Okay, wait. And others? Anyone else? Bhargavi, Bhagyashree, Gargi, Durg, Gaurav, Lishika.
Sir, I think it should be 32. Sir, I think it should be
Oh,
32.
okay, I'll give you some time, some more time. Yeah, okay, you tell me 64. You are increasing the value. Only one guy is giving the answer. At least whether wrong or right, I don't know. Others are not giving.
Sir, these DFS should be minimized, right?
Madam, already I gave you 2 states. With those 2 states only, you have to use 2 states, all the 2, and 2 inputs. Every state must be different for every input. At every state for every input, it must be single. So that how many DFS you can construct? Phone? Huh? Phone? Nikhil Jha, Neeraj Kumar. Answers, please.
So 32 handwritten.
Who? Bhargavi, 32.
32, sir.
Okay. What about you, Bhagyashree?
Sir, I think 64.
64. This is Gargi, na?
Yes, sir.
How? Mister, someone has told me that 16 after the 32. What is your final answer?
Sir, 32 is not.
Okay. Q0 is initial. Always. Q1 is the other state. And we want to construct a DFA. So present state and the next state. Inputs are 0 and 1. And the states are Q0 and Q1. And Q0 is initial. Okay. Now in Q0, come to this diagram. On 0, you must define. So Q naught on 0, I can go to this, I can remain in the same state, or I can go to Q1. So I can define either Q naught itself or I can go to Q1. So Q naught on 0, you have to go for only one state, either Q naught or Q1. So anyway, we have two possibilities. In two ways you can construct. Similarly, Q naught on 1, you can go to Q1 or you can remain in the Q naught. So Q naught on 1 also you have two options, two possibilities. Are you following? So Q naught on 1, either I can remain, Q naught on 0, I can either remain in Q naught, or Q naught on 0, I can go to Q1. So we have two options. Similarly, Q1 on 0, either you can remain in the same state or you can come to Q naught. So here also Q1 on 0, you have two options. Similarly, Q1 on 1, two possibilities. So two possibilities in at every state for every input. Do you have any doubt? Hello, do you have any doubt?
Yes, sir. Doubt. Sir, if we yes, sir. I have a doubt. So if we go to Q from Q naught, if go to Q naught for 0 and 1, then Q1 will become redundant. Like it won't be the minimized DFA, right?
Just leave it. Okay, just I'll continue. I'll come back to you after some time. Okay, Miss, do you understand? Okay, so Q naught on 0, you can go to Q naught or you can remain in the Q naught. So anyone, either this or that. Similarly, Q1 on 0, you can remain in the same state or you can go to this Q naught. So you have two possibilities. So like that. So total 2 into 2 into, so this is 2 into 2 into 2 into 2. So 2 power 4, 16 options. Okay. In these two states, no one is final. So with no one is final, you will have 16 different DFAs. Next time what I do, I will take Q1 as final, but Q naught is as non-final. But always this is initial. So again we will have 16. So whatever the 16 we got here also the same 16 will get. But these 16 and these 16 all are different because in the first 16 there is no final state. In the second 16 there is a final state. And next one, I will take initial as final and Q1 as non-final. Again, the same, structurally the same 16, whatever we got this year and year also will get. But these 16 are different. All these 16 are different when compared to these previous 32. Because in this previous 32, the 16 plus 16, initial is non-final, whereas initial is final in this. Okay. Next, in the next one, I will take both as final, Q naught as final as well as Q1 also final. Again, the same 16, the structurally will get the same, but functionally here, these Q naught, Q1 as here, both are final states, and these all 16 are different from these 16. So totally 16, 16, 16. How many? We have 64. There will be 64 DFAs. Now come to this one. In any automata, if you take a state Q naught can be a final or a non-final. Only two ways you can represent. Similarly, Q1 can be a final or non-final. Two ways you can represent. So 2 into 2, 2 into 2, 2 square into 2 power 4. You will have 4 into 16. That is 64 is the answer. Okay. Now just copy this one. I'll tell you. I will clear your doubt. Bhargavi, I think.
No, sir, Devanshi.
Devanshi, sorry. Okay. Copy this one.
So the last diagram which you have drawn, then all strings have to be accepted in that. So it is not a minimal DFA, right? Minimal DFA will be single state with A comma B. So we have to compulsorily take 2 over here.
What is the question here?
So maximum number of DFAs.
Did I ask you the maximum number of minimal DFAs? Always minimal DFA will be only one. Then how do we get these many DFAs? So minimal for any language, if you consider DFA, that DFA will be only one. Minimal DFA will be only one. Of course, you can construct any number of DFAs for any language, but the minimal DFA will be only one. I didn't ask you even just the number of DFAs. That's it. The number of different DFAs. The number of different DFAs that can be drawn with the two states over two inputs having always Q naught is initial. That is the question. Okay, copied this. Every one of you. Now, hello, shall I go forward?
Yes, sir.
Devanshi. Present state, next state, 0 and 1. Q naught, Q1. Q naught is initial. Devanshi, Q naught and 0, where can I go? Oh, sorry. Devanshi, some girl has asked me that out. Q naught and 0, where shall I go?
Yes, sir. We can go to 0 and 1.
Or I can go to Q1. It is okay?
Yes. Yes.
Q naught and 1. I can go to Q naught. I can remain in Q naught. I can go to Q1. So, it is okay?
But then
One second. Q1 and 0.
then we can't reach Q1, right?
Okay, no problem. What is the problem here? What is the DFA? When two states, whether it is reachable or unreachable, just forget about this one. When two states are given, if they are these satisfying the two conditions? Okay, of course, you are right. There is no transaction from Q0 to Q1, but the two states are given. Q0 and 0 is Q0, defined. Q0 and 1, defined. Q0 and 0, single. Q0 and 1, single. Q1 and 0, defined. Q1 and 1, defined. Q1 and 0, single. Q1 and 1, single. It is single, single, single. So it is satisfying both the conditions, two conditions being satisfied. So this is DFA. Whether it is, okay, that is the reason. One girl has asked me, are you asking the minimum number of? No, I have not mentioned the minimum number. The different number of DFAs. Yes, this is also a DFA. But when we come to the minimal, then definitely this Q1 is not necessary here. Not at all we require in Q1 because it is unreachable. Unreachable state will be deleted. That is a different story. When two states are given, if you have to consider the DFA, so you have to satisfy the two conditions. How many DFAs we can construct? Different DFAs. So no one can be the final, any one only final, both can be final. Like this, I will have 64. Now you please continue your doubt, Devanshi.
Yeah, understood, sir.
Okay then. Thank you guys. So tomorrow we'll continue more questions. I'll give you based on the same data. Okay, more interesting questions we can do. Shall I? Okay. Stop.
Yes, sir.